Here we go again, another Mikey Pipes service call. This time we're on a Hayward Summit XL heat pump pool heater throwing a dPc error code. But the real problem? A broken wire hiding inside the unit. Let's get this pool heater back in business.
All right, we are at our next service call. Hayward pool heater defrost error. Let me just let them know I've arrived. No one's home. Oh, there it is. All right. So we got a DE filter. We have an ECM pool pump. We have a Hayward Summit XL pool heater. Let's get set up, fire up, see what's doing. All right, let's turn power on. All right, we have condenser fan motor pops on. That's the first order of operation. Let's see what we're in. Set for 86. It is in that heat mode. Let's see how this thing operates. There's a little bit of a delay here. dPc. It's defrost thermistor error. All right, let's pop out these screws, which I absolutely hate. Plastic into plastic, like it really makes no sense. There are 5 screws, 2 on both sides, upper and lower, and then 1 in the middle. And then the bottom pulls out, drop it down. We'll put that off to the side. Where is the rating sticker? Sticker's gone, huh? Yep, you see? Maybe it's inside front cover. Let's take a look here. Ooh, what's going on in there? A lot of I don't know. Just checking just doing a visual inspection. All right, nothing out of the ordinary. All right. And it reset. Interesting how that error message went away and now it's rebooting. So I'm leaning towards a logic issue or a control board issue. Well, let's briefly talk about what dPc and also could be SHC error message. And now it just turned on the display. If you have it basically it's indication of a shorted water temperature sensor. Right now we're in high pressure, and that's because my door or the cover is open. Let's put the cover back on. So now we have that high pressure error. That means that the system sensed high pressure on the refrigerant side of things, not the water side, not the pool side, right? But let's quickly go back to that dPc error. That's an indication of a shorted water temperature sensor. Common causes or as a shorted defrost sensor. We have checked for any of the wiring for any shorts, and then check the sensor for resistance against the actual temperature of the pool. So if the resistance reads like very low or 0, you're going to replace the sensor. If the sensor is reading the correct resistance for the temperature of the pool water, you're going to end up replacing the board. Right now I want this HP to go away. Back to pool. We'll go through a time delay for that compressor to start up, and let's see if the error comes back. So we have that dPc error, which is water temperature sensing issue, and HP. If HP comes back and our coil is clean and our fans weren't working, then we more than likely have a control board issue, and we'll have to order that board for them. All right, the compressor just kicked on. actively running. Let me grab a digital psychrometer to read the outlet temperature of this heat pump. See what our temperatures are on top. $59, $58. So right now we are actively heating the pool. That temperature sensing fault error, dPc, may have been a short. So now we're going to have to investigate that, because the only thing I did was take the cover off and we had that error message, and then it went away and then it came back. So we either need to check our wiring, and then if all that checks out well, and we'll check out the resistance of the temperature sensor, you could have a logic issue. So that would be a control board, the main PCB. Right now it's cooling. It's heating. 58.2 degrees on our outlet temperature, 58.4.5. We are actively heating this pool. It's running. If I take the cover off, we're going to have that HP error, because now we're not having that heating exchange going on with that coil, right? You know what? I'm surprised I missed this. I say this time and time again. A good technician is observant of their surroundings. Take a look at that. I totally missed this before. See that? Look at that. Wow. We totally missed that. Crazy. I can't believe I missed that. See that black and red wire right here. Look, check this out, folks. There it is. That's our error. It's been a problem once before. As you can see, everything's wire nutted here. So what I am going to do is we're going to eliminate this here, since the temperature sensor is right there. We're going to run this line. We're going to drill a hole in the bottom right here. We're going to clean out the electrical compartment. We'll drill a hole in the bottom. Actually, no, we have a hole right here. Sorry. Hole right there, and we're going to wire it right to there. We're going to eliminate that disaster that's going on here, and we'll be fine. All right, so let's take this out right there. Okay, this is that, which is going to there. Let's just undo those two screws on those terminal right. Okay, so there's that wire there. Pull this out over there. Now, I don't have the breaker off, I just have the switch off here, so we're gonna be aware of our surroundings. And there it is, folks. Insane. Crazy. Okay. There those are. Now, it's a little short. I'm just gonna keeping it real here, right? So we're gonna leave a little note on this pool heater. I'm thinking about extending it, but I'd rather not extend this. That way I could just keep that communication without having any wire nuts or anything, kind of like how that one. I wasn't gonna wire nut it again. Come on, no. I'd rather not use a wire nut unless I really have no choice. So let's get this in there like that, and I'll screw that in. All right, they are both secure. There's some kind of creature up here, right? Had to be some kind of creature, and it was just nibbling on the wire. It's crazy. Let's turn the power back on. Let's get the door on, and we'll leave a little note here. Putting the screws back in for the cover. Now, one of the things you really gotta keep in mind is when you're putting these screws in, It is not the, I don't know, it's a stupid idea and way, however this was engineered, putting screws in here like this. I'll tell you a story. About a year or two ago, I'm working on a Hayward pool heater. We had a refrigerant leak on it. I made the repair. I didn't replace the filter dryer. I'm just keeping it real. I didn't remove the Schrader cores, but I recharged the system with refrigerant. The rating plate was here, by the way, and I didn't notice, but the screw that I was putting onto this right-hand side, or maybe it was the left-hand side, was longer than what's there now, and I drilled it right through the coil, and all the refrigerant leaked out. Literally, it was a Friday afternoon, like 1 o'clock, 2 o'clock. I'm just about done, and I'm not paying attention, and I put a longer screw here than necessary. Let me ask you a question. Why would you have a coil go all the way to the bottom right here, and you're putting screws in there? It's dumb. It really, really, really is dumb. But it is what it is. Right now, let's check our temperatures. Let's set that for 85, and ask the homeowner how they want this thing set to. Right now it's 73. We'll check some outlet temperatures on the pool water, and be good to go. All right, compressor is running. I am not a fan of checking refrigerant temperatures and pressures by hooking up my manifold to the service ports unless I suspect there's a problem. Every time you connect your gauges, whether it's probes or analog, digital, or hoses, anytime you connect your equipment to the system, you have the potential for something to go wrong. So unless I suspect there's a problem, listen, if I put my hand on top of there and it's just ambient temperature air and it's not cold like the way it should be, because right now we're extracting heat from the ambient outdoor air temperature, right? We're extracting that heat. The refrigerant is that medium. The compressor is making these things happen, and it's transferring that heat that's extracting from the temperature outside into your pool, which is why when you put your hand on top of the unit, right, it's cold, right? Look, it's 57 degrees, but it is 77 degrees here right now, right? Same principle when you're working on your air conditioning systems, right? When you approach an air conditioning unit and it's running and you have hot air coming out of the top of the unit, that is the heat being extracted from your house to outside, and that refrigerant is the medium. Here it's the same thing, it's just all in one box, right? So you're extracting the heat from the air, right, and dumping it into the pool, and the result is cooler air temperatures coming out of the top of the unit, right? Similar, if this condensing coil if this evaporator coil is clogged, right, you're going to have high pressure. Same way if the fan motor is dead or the cover is off, like we had earlier during the beginning of the service call. So you got to be situational awareness, be aware of your surroundings, and know how things work. And like I said earlier, I'm shocked that I missed that. I wasn't paying close enough attention. You know, the wires for the temperature thermistor on that insulated refrigeration line. I missed that, but that caused the issue that we're having here. And fortunately for them, we were able to fix it. All right, at the client's request, I set the heat pump to 88 degrees. It's reading 73. Before I check out and leave, make sure everything else is okay. Temperature 74. Our pool pump, I think, is running at 80%. Let's wait for it to air temp is 81. And pool chlorinator running at 65%. Salt level 3,000 particles per million, or parts per million. Filter speed 80% speed 2. I want to see the RPMs. No, Friday. Okay, guys. Friday at 9:43. We good to go. Thanks for watching. If you enjoyed this kind of video, smash that thumbs up button. If you have any
now,
thoughts,
ladies and gentlemen,
criticism, drop
if
that
you
down
have
in the comment
a
section
Hayward
down below.
Summit
The best
pool
way you can
heater,
support
it's
the
very
channel is by
important
hitting
that
that
you
subscribe
check
button.
the
Thanks for watching.
resistance
Until
on
next
the
time, be well.
thermistors
God
for
bless.
both the
Stay
defrost
safe.
and the water. So I have on the screen right now that temperature and resistance chart. So based on the temperature equals a certain value, and that is measured in ohms, K ohms, as noted on this temperature resistance chart. This is for the Summit. If you have a Heat Pro and not a Summit, looks identical but slightly different, only because on the Heat Pro heat pumps, they're using a 10,000 ohm sensor to measure resistance, unlike the Summit, which is 4.8 K ohms or 1,000 ohms. Temperature equals temperature in Fahrenheit or Celsius equals a certain resistance, and that's measured in K ohms, 1,000 of ohms. Okay, there that is, as well as pictures for both the Summit sensors and the Heat Pro sensors.